For today's video, we're going to talk about piecewise functions. Let's start with the definition. For the definition, when we say piecewise functions, in here, you have two or more definitions, depending on what part of their domain or the input you are talking about. Piecewise functions have a huge place in business, where people charge different prices depending on how many items you're buying, or where companies charges for utility usage based on the quantity that month. Even the income tax is piecewise, with the percentage rate determined by your income. Let's begin with this example. So in here, we have f of x is equal to negative 2x minus 1 if the value of your x is less than or equal to 2, and negative x plus 4 if x is greater than 2. So in here, you have two sets of domain. So for the first set, that would be x is less than or equal to positive 2. When you have those values, then you will use f of x is equal to negative 2x minus 1. Otherwise, if the value of your x is greater than 2, you will use f of x is equal to negative x plus 4. So before we solve for this example, before I gave you some of the examples here, let me state the set first. So in here, when we say x is less than or equal to 2, meaning we are talking about the values such as positive 2, including positive 2, then positive 1, 0, negative 1, negative 2, and so on and so forth until you reach negative infinity. Those values would be less than or equal to positive 2. When we say x is greater than 2, so meaning we will start with 3, 4, 5, and so on and so forth until you reach positive infinity. Using this function or piecewise function, let me give you some values of x that we need to solve. Suppose we have f of negative 2. So in here, we need to decide which function should be used. Should it be negative 2x minus 1 or should it be negative x plus 4? So look at the domain and you will know which function or which definition should you use for this one. So since this is negative 2 and we know that negative 2 is less than 2, meaning we need to use negative 2x minus 1. So in here, what you're going to do is to substitute negative 2 to negative 2x minus 1. So this will be negative 2 multiplied by negative 2 minus 1. And that would be equal to negative or rather positive 4 minus 1. And that would be equal to 3. So meaning f of negative 2 is equal to positive 3. Let's have another example. Suppose we have f of 0. So we need to decide, is it negative 2x minus 1 or is it negative x plus 4? Since we know that 0 is less than 2, meaning we will use the same function here or the same definition here. So this will be negative 2 multiplied by 0 minus 1, and that would be equal to 0 minus 1, and that equals negative 1. So meaning f of 0 is equal to negative 1. So what if we have f of positive 6? We know that positive 6 is greater than 2. So meaning we will use negative x plus 4 as your definition here. So we will substitute positive 6 on the values of x here. So this would be negative 6 plus 4, and that would be equal to negative 6 plus 4, and that equals negative 2. Meaning f of 6 is equal to negative 2. Let me give you another example. So in here, we have three definitions. So first would be f of x would be equal to negative 4 if the value of your x is less than or equal to negative 2. F of x is equal to x minus 2 if x is greater than negative 2 but less than 2. Meaning to say this will be in between negative 2 and positive 2, not including negative 2 and positive 2. And lastly, f of x is equal to negative 2x plus 4 if the values of your x is greater than or equal to positive 2. Let me give you the set on each domain here so that you won't be confused. So when we say x is less than or equal to negative 2, meaning negative 2 is included here. So we will list those values. So we have negative 2 included. Then when we say um, less than negative 2, that would be negative 3, negative 4, negative 5, and so on and so forth until you reach negative infinity. When we say in between negative 2 and positive 2, that would be positive 1, 0, and negative 1. Take note, decimals will also be included here, such as 1/4, 1.99, negative 1.5, as long as you don't reach negative 2 and positive 2. And lastly, when the value of your x is greater than or equal to 2, meaning positive 2 is included here, then increasing, the values are increasing. So that would be 2, 3, 4, 5, and so on and so forth until you reach positive infinity. Let me give you values of x's here. So first, let's say we have f of 0. Second would be f of 1 over 4. Third would be f of positive 4. And fourth will be f of negative 6. So let's begin with f of 0. So on which function or on which definition does f of 0 lies? So look at your set. You will know that it will be on the second definition or the second function. Meaning we will substitute 0 to x minus 2. So this will be equal to 0 minus 2, and f of 0 is equal to negative 2. Next will be f of 1/4. F of 1/4 will be under in between negative 2 and positive 2, meaning we will also use x minus 2 here. So this will be equal to 1 over 4 minus 2. Let's convert 2, making it similar to 1/4. So this will be 1/4 minus, so the easiest way would be 2 multiplied by 4, that is 8. Then just copy the denominator. We know that 8 divided by 4 is also 2. The purpose of this one is for you to be able to subtract the fraction here, because since in subtracting or adding fractions, your denominator should be the same. Next will be subtracting the numerators. So 1 minus 8, that will be negative 7. Then we just need to copy the denominator. So meaning f of 1/4 is equal to negative 7 over 4. Next will be f of 4. F of 4, we know that it is greater than 2, meaning we will use the third function rule here. So this will be negative 2, then we will substitute positive 4 on the x here. So this will be positive 4 plus 4. So this will be equal to negative 8 plus 4. And negative 8 plus 4 will be negative 4. So meaning f of 4 is equal to negative 4. And lastly, we have f of negative 6. Since we know that negative 6 is less than negative 2, meaning we will use the first function rule here, which is negative 4. You cannot see any variables here, meaning we don't need to substitute any values. We don't need to substitute negative 6. As long as you have values less than negative 2 or equal to negative 2, the answer would be automatically negative 4, since negative 4 is already a constant. So f of negative 6 would be negative 4. Let us proceed to the third example. On your third example, we have the definitions also here. So f of x is equal to negative 2 raised to x if the value of your x is less than negative 4. When we say x is less than negative 4, we are talking about the values less than negative 4. So that would be um, negative 5. Then decreasing, so that would be negative 6, negative 7, and so on and so forth until we reach negative infinity. We will use the negative absolute value of x if the value of your x will be in between negative 4 and 0, including negative 4 and 0, because your sign here would be x is greater than or equal to negative 4, but less than or equal to 0. So those values will be negative 4, negative 3, negative 2, negative 1, and 0. So those are the exact values here. Lastly, we will use 4 minus x squared if your x is greater than 0, meaning that would be positive numbers starting with 1. So that will be 1, 2, 3, and so on and so forth until you reach positive infinity. Let's try to answer the following questions here. So let's say we have here f of negative 6, f of 0, f of negative 2, and f of 10. Let's start with f of negative 6. We know that negative 6 is less than negative 4. So meaning we will use the first function rule here, which is negative 2 raised to x. So what we're going to do is to substitute negative 6 to this x. So this will be negative 2 raised to negative 6. Whenever you have negative exponents, what you need to do is to get the reciprocal to make it positive. So meaning this will be negative 1 over 2 raised to 6. And this will be equal to negative 1 over 64. So let me erase it first. So negative 1 over 64. So the value of f of negative 6 is negative 1 over 64. Next will be f of 0. So as you can see, f of 0 lies on the second function rule, which is the negative absolute value of x. So this will be negative absolute value of 0. So since 0 is neutral, the answer here will be 0 only. Next will be f of negative 2. So f of negative 2 will be in between negative 4 and 0. So this will be negative equal to negative absolute value of negative 2. We know that the absolute value of negative 2 is positive 2 because we are talking about the distance of negative 2 to 0 and there is no negative distance. So this will be negative times positive 2 and negative times positive 2 would be negative 2. So f of negative 2 is equal to negative 2. And lastly, we have f of 10. So f of 10 is greater than 0 and it's positive. So meaning we will use f minus x squared. Or rather, f of x is equal to 4 minus x squared. So this will be 4 minus 10 squared. So we will simplify the exponents first. So this will be 4 minus 100. And 4 minus 100 is equal to negative 96. Let's proceed to the fourth example. On your fourth example, we have here wx or w of x is equal to the absolute value of x minus 3 if x is less than 1. Quantity x minus 1 raised to 4 if x is equal to 1, and square root of 4x if x is greater than 1. So in here, if x is less than 1, we are talking about numbers less than 1. So that will be 0, then negative 1, negative 2, and so on and so forth until you reach negative infinity. If x is exactly 1, meaning it's only 1, then x is greater than 1, so meaning that would be positive 2, positive 3. So increasing values until you reach positive infinity. So let's try to solve the following. So we have here f of 1, f of negative 4, f of 2, and f of 4. Let's start with f of 1. Since we see this one as exactly 1, so if x is equal to 1, you only have one function rule here, which is the second. So this will be quantity x minus 1 raised to 4. So we will substitute it here. So this will be 1 minus 1 raised to 4. That will be 0 raised to 4. And that will be 0 only. So f of 1 is equal to 0. When you have f of negative 4, we know that this is less than 1. So we will use the first function rule here. So this will be equal to the absolute value of negative 4 minus 3. Let us simplify the values on inside the absolute value first. So this will be the absolute value of negative 7. And the absolute value of negative 7 is positive 7. So meaning f of negative 4 is equal to positive 7. Next will be f of 2. So f of 2 that is greater than 1. So we will use this function rule, the square root of 4x. So this will be equal to square root of 4 times 2. Since 4 is a perfect square, we will get the square root of 4. So this will be 2. The square root of 4 is 2. That will be outside the radical sign. And 2 is not a perfect square, so it will remain inside. So f of 2 is equal to 2 square root of 2. And lastly, we have f of 4. So that is greater than 1. So we will substitute it on square root of 4x rather. So this will be 4 times 4. And we know that 4 times 4 is 16. And the square root of 16 is positive 4. So meaning to say, f of 4 is equal to positive 4. Let's proceed with your last example. On your last example, what we have here is x plus 5 if x is less than or equal to 3. So meaning to say we will include 3 here. So 3, then decreasing values. So 3, 2, 1, 0, negative 1, and so on and so forth until you reach negative infinity. And 2x minus 1 if x is greater than 3. So values greater than 3 will be 4, 5, 6, and so on and so forth until you reach positive infinity. So let's try to solve the following values of x. Suppose we have here f of 3.2, f of 3, f of negative 6, f of positive 10. So let's start with f of 3.2. We know that 3.2 is greater than positive 3. So we also include here the decimals, the fractions, as long as it's greater than 3. So meaning we will use 2x minus 1 as your function here since 3.2 is greater than 3. So this will be equal to 2 multiplied by 3.2 minus 1. 2 multiplied by 3.2, that will be 6.4 minus 1. And 6.4 minus 1 will be 5.4. So f of 3.2 is equal to 5.4. Let's now proceed to f of 3. F of 3, since this is exactly 3, meaning we will use the first function rule. Because the condition here is if x is less than or equal to 3. So meaning to say we will use this one. So this will be equal to 3 plus 5 and that will be equal to positive 8. So meaning f of 3 is equal to positive 8. Next will be f of negative 6. So f of negative 6, we will use the first also since negative 6 is less than 3. So this will be negative 6 plus 5, and negative 6 plus 5 is equal to negative 1. And lastly, we have f of 10. F of 10 is greater than 3. So meaning we will use the second function rule here. So this will be 2 multiplied by 10 minus 1. 2 times 10 is 20 minus 1. And that equals 19. So f of 10 is equal to 19. That will be all for this video. Hopefully you learned about piecewise functions. If you have any questions or suggestions, you can leave a comment down below. Please don't forget to subscribe and click the bell button so you will be notified every time I upload videos. So once again, that is our math minute for today. Thanks for watching.